Okay. So we are going to first look to see. Now, those of you who struggled, did you write out the steps off to the side so you could do them? Ah, you only squared one side? That can happen. Do we still need to do number 2? Yeah? Okay. So first thing we have to do is add or subtract a number to the other side. Is there a number available to add or subtract over? I shouldn't see any Chromebooks. We're not using them, so let's put them away. Yes. There should be a copy over there. All the way to the right by the black box. Yeah. Subtract 15. And with the Chromebooks, I don't even want to see them out. They shouldn't even be on your desk. They should be in your backpack. So Chromebooks all the way in your backpack. Okay. Okay. Yeah, so the next step was, could we multiply or divide anything over to the side? We can't. The 4 with the k is trapped underneath the square root, so we can't get to it yet. The next step is, can we get rid of an exponent, or could we introduce an exponent? Yes, we can square both sides. So when we square a square root, they cancel. We get 4k minus 11 equals 169, okay? And then now we've gotten inside the grouping symbols. They weren't parentheses in this case. It was the inside of the square root. But now we're going to go back to the beginning. We're going to add the 11 over to the other side. What is 169 plus 11? 180, okay. And now we can multiply or divide something to the other side, and you guys said divide by 4. So k equals 45. And I couldn't do this at home, but I can do it now. I'm going to take my calculator. I'm going to do 45 stored as x. And the only people not clicking right now are the people who have already checked this. Is that right? Everybody else is clicking because they're checking it. And we're going to do square root of 4x minus 11 plus 15. We're going to verify that it equals 2. And if it doesn't equal 2, what's our conclusion going to be? No solution is what our conclusion is going to be. So this equals 28. It does not equal 2. So our answer is no solution. Yeah, so cross out the 45. That way I know that you solved it and you got the right wrong solution. Yeah. Why would you what? So 2 is what the original problem said it was supposed to equal. So I typed in the original problem to see if it did equal 2. Now, whenever this happens, usually the issue is that it's because we have a positive square root. If we were to have had a negative in front of the square root, then it would equal 2. So it's just unfortunate they only had the positive version.
What if it's like number 7? So instead of just cleaning number,
We will get to one like that. We'll do one like that today. Yeah. Okay. We also wanted to look at number 3. So let's do that.
how do you do the fourth root on the calculator?
You type a 4 first, and then you hit the math button, and then you go to the one that says n root, and it will take the 4 and it'll put it in for the n. Yep. Okay. So first, is there something we could add or subtract to the other side? No. Is there something we could multiply or divide to the other side? Okay, divide by -7. Was that the step? Yeah, okay. So we've got 4th root of m plus 1 equals what? -2, okay. Next step, is there an exponent we could get rid of or an exponent we could introduce? Introduce 4. Okay, raise it to the 4th power, raise it to the 4th power. Cancel those. M plus 1 is 16. Positive or negative? Positive. Okay, it was a trick question. You passed. All right, we had grouping symbols. It was the radical. We got inside them, so now we're back up to the beginning. Subtract the 1. M is 15. Okay, so now I'm going to check my answer. Says -14. All right, so if when we store it and we type this in, this is a good one to type in though because this is kind of hard to type. So I'm going to do -7. I think the trick is to say, instead of -7 and then the 4th root, say times 4th root. That was the answer. Whatever the answer is, that's what you store.
I heard that whatever the number is at the top, you store it.
I'm the teacher, so I know how to do it.
No, I'm saying that's what I heard.
So what you heard is wrong. So whatever the answer is, that's what you store. So I'm storing the 15. Now I'm typing in the equation at the beginning, and I'm going to see if it equals, it's supposed to equal 14 when I plug the answer in. Okay, so -7 times, now I'm typing in a 4th root, so I'm going to hit 4 for the 4th root, and I'm going to hit the math button, and I'm going to go down to option number 5 to get x in there. There we go. And it took the 4 and it slurped it in, and it said, yep, there's a 4th root for you. X plus 1. The calculators are magical. I love them. Yeah. Okay, and we want to see if it equals positive 14, and it does not. It equals -14. So what is our conclusion? No solution. Bam. No solution for you. Well, you have to solve for the answer to see what the answer is before you can type it in. Yeah. Yeah, got to do some work first. Okay, so we know enough math to do number 5 or 6, so we're gonna hold off on those for a second. But number 7, we haven't looked at one of those yet, and really, it's not going to be terrible to do one of those, but the checking of the answer is definitely different, and so we are going to do this one together. Okay. Hi, you ready? Okay. All right, so we have a square root and a square root. So with this one, anytime you have a variable on both sides, you're not going to be able to do the order of operations backwards. Order of operations backwards only works if you have a variable on one side. So if we have a variable on both sides, we're just going to have to use kind of what we've learned about math in the past to think about how do I get the variable alone. But if we have a radical on both sides, is it safe to say it makes sense to square both sides to get rid of it? Okay. So I'm going to go ahead, and my first step is going to be to square both sides just to get rid of that radical. And so I end up with 3k minus 29 equals 41 minus 2k. And then this no longer even feels like a radical equation. Now it just kind of feels like a normal equation. And so what should I do now to get the variables all to one side? Add the 2k. It does not matter which side. A lot of students will do what you just did, which is keep the k's positive. But it's okay if you do that on the left side or the right side. It doesn't really matter. Okay, so we have 5k minus 29 equals 41. And now I'm going to keep the 5k's over here. So what should I do with the 29? Add the 29. 29 and 41 is 70. 5k equals 70. So I'm going to divide by 5, so k equals 14. Okay, so since our answer is 14, that is the number I'm going to store. So I'm going to say 14, I'm going to store it as x. Now this time we don't have like the whole equation equals a number. We have a piece of the equation on the left side and a piece of the equation on the right side. So what we're going to do is we're going to type in the left side and see what it equals, decimal, whole number, whatever. We're just going to see what it equals. And then we're going to make sure that the right side equals the same thing. So I'm going to type in square root 3x minus 29.
When you do one of them, do you have to put in the store thing again?
Yes, you have to store your new number. So here's the left side. Now that decimal is what the right side should equal as well, for me to make sure that my answer is right and that it shouldn't be just no solution. So square root 41 minus 2x, there's the right side. My left side and my right side are the same, and so my conclusion is that that answer was good. It was not a no solution answer. Are we okay with how number 8 looks, or would we rather have it as a radical? The 1/3 is weird, so let's rewrite it as a radical. So this is going to be a third root equals a third root. And so what would we do first? We'd get rid of the root, and how would we do it? Yeah, cube each side. Now, if you had not written it as a radical, you would still do the same first step. You would still take each side and raise it to the third power. And then using your exponential rules, you would say that 1/3 multiplied by 3 is what? 1. 3/3, which is 1. So 1/3 multiplied by 3, those exponents basically cancel each other out, and you end up with what is underneath the exponents, which was 3x minus 21. So you can do the problem either way, but usually students have one way that feels more comfortable. And I'm the same way as you, Gracie. I prefer having the radical. So I usually rewrite it that way as well. So we have 3x minus 21 equals 19 minus x. And now we're just at a regular equation. So what should we do? Add the x, okay. So 4x minus 21 equals 19. Add the 21. 4x equals 40, okay. Divide by 4. X equals 10, okay. So I'm going to take that answer, I'm going to store it. So 10 stored as x. Okay, and when I type this in, I always go back to the original problem to check my answers. So I'm going to do 3x minus 21 to the 1 divided by 3. So you can type it in as 1/3, the fraction 1/3, but you can also do 1 divided by 3 because it's the same thing. So there's my decimal for the left side. 19 minus x. What'd you say? You got to put the 1/3, yeah. 19 minus x to the 1/3. Same thing. Although in theory, I guess if they're raised to the same power, then the bases should be the same. So technically you don't have to put in the 1/3. Yeah. But we get the same thing on the left side and the right side. So we know that it's correct. Okay. So let's go ahead and practice some of these. You guys are going to do 5 and 6. So those are similar to what we did yesterday. We can definitely handle those. And then I'm going to have you practice, oh, of course, no, none of them look like the ones on the front. I think, oh gosh. Do 5 and 6. Do 5 and 6 for now, and then I'll write down different problems for you guys, okay? So go ahead and do 5 and 6, and then I'll let you know what to do after that.